Next, chemical bonding. Chemical bonding, we have few parts here. So chemical bonding, we always can differentiate by seeing at them. So for chemical bonding topic, we really need periodic table. So periodic table will help you to identify whether your particular element is whether metal, non-metal. Because your bonding always involves metal, non-metal, right? So chemical bonding involves electrons. You have to know electrons. How many electrons are there? So how am I supposed to identify the electrons? So the electrons and electron number and proton number is the same. So when I can find my proton number from the periodic table, I can also find my electron number from the periodic table, from the particular proton number, right? So it is the most important shell is the outer one in the sense of valence electron. So the most outer shell. We call the electron in outer shell as valence electron because they are used for bonding. So only the last valence shell. That's why if you notice in questions, they use to only draw the outer shell. Because the inner shell doesn't mean that we don't need that, but we won't need it as much as the valence shell importance. Okay, and because the outer shell is the same elements group number. Okay, one more tip to identify. How am I supposed to know how many electrons there must be in the valence shell? So where the valence electron is placed, that is your valence shell. So how many valence electrons must be there in the valence shell? How am I supposed to know? By looking at the periodic table. We can identify that. How are we going to identify that? Okay, in the periodic table, we have how many periods? 7 periods and 18 groups, right? So 7 periods and 18 groups will indicate to us that that particular element having how many electrons and how many shells. So we're supposed to know shell is what? The round circular orbit which is around the element, which is around the atom. So around the atom, the electrons will pass by. So when the electrons are passing by, so that particular orbit, so remember the galaxy. So the orbit is the galaxy orbit. So the electrons are the orbits who are traveling through that. So your electrons are the one. So when your electrons are passing through the orbits, so that orbit is your shell, and then the electrons is the orbits, right? So we have to know how to identify how many shells must be there. So the period, which is period 1 to period 7, will tell us how many shells must be there in that particular element. So if let's say sodium in which period? So sodium is in 3rd period, means the sodium's arrangement supposed to be 3 shells. Okay, if let's say sodium is in group 1, so your group 1 up until group 18, they will tell you how many valence electron must be there. So that means if group 18 means are there 18 electrons in that valence shell? No. We only take, if let's say there are double digit, if let's say group 1, there's only 1. So the valence shell will have 1 electron. Group 2, there's only 2. So the valence shell must have 2 electrons. If let's say 18, group 18, do I have 18 valence electron in the valence shell? No. I only will see the 2nd digit. 2nd digit will tell me 18 means 8. So there's supposed to be 8 valence electron in my valence shell. Understand? And the number of electrons around the atom given by the atom's proton number. Again, and then the first shell holds 2 electrons. So this is norm. You cannot change the norm. This only will not be applicable for hydrogen because hydrogen proton number is just 1. So the hydrogen's electron is also 1. So this norm, which the first shell must have electron, this norm doesn't apply to hydrogen. So that's why hydrogen is quite special. Although when we are talking about group 1, we won't touch hydrogen because one thing, hydrogen is gas, and another thing, hydrogen don't fall inside metal group because group 1 must be metal, alkaline metal, and your group 2 supposed to be alkaline earth metal, right? So your group 1, Hydrogen. Hydrogen is exceptional case. Except for hydrogen. Other than hydrogen, if let's say lithium, sodium, potassium and all that are in group 1. So when they are in group 1, their valence electron supposed to be 1. Right? Let's say lithium. Lithium's proton number is 3. Okay? Proton number is 3 and lithium is group 1. And the last shell, I'm going to use the board. Okay, this is lithium. So lithium has 2 shells. Why? Because lithium in period 2, group 1. And lithium, if we notice the first rule, which is the first shell must have 2 electrons, means I must have 2 electrons, compulsory, right? And my second shell, which is my valence shell. And the electron who's supposed to be is my valence electron. Is my valence electron. So here, this one indicates my group 1. And these 2 indicates my period 2. So that's why I'm having 2 shells and 1 valence electron. Period gives the number of shells and also gives the number of electrons in the outer shell. For example, chlorine is in group, period 3, group 17. So if let's say group 17, what is supposed to be, and then it has 3 shells. So for chlorine, it has 3 shells. And the arrangement of electronic configuration, it always, first shell, 2 electron, second shell, 8 electron, third shell, 8 electron, and followed by 18 electron. But then we will always follow 2, 8, 8, 8. In exams, we always won't have the privilege of us identifying more than 25 electrons. So we always have questions which is less than that. So we won't have that confusion. Third shell how many? Fourth shell how many? So we already fixed by this arrangement. So if let's say chlorine is in period 3 and group 17. And this one will tell me my last final shell supposed to have 7 valence electrons, which is 1, 2, 3, 4, 5, 6, 7. And this one got no pair. And this is where I must bring in a friend for this electron. And the friend will help this electron to get paired and will make this whole element to be stable. Why do I need to make the atoms to be stable? Because when we are pairing one element with another element, they have to pair in a stable way. So for example, I'm pairing sodium and chlorine. So I'm pairing them. If let's say one of them is not stable, okay, for very, very layman example, if let's say 2 of you are friends, so 2 friends becoming friends, and then one of the friend mentally not stable. Can you sustain in that relationship? You cannot. So you need someone who is stable and who is very much clear. So in that sense, whenever the element has 8 valence electron in their valence shell, that means that the element is stable. So the 8 valence electron must be over here, right? So in the valence shell, the 8 valence electron will identify whether the element is stable or not, right? So if we come here, so period 3 period, and then 7 valence electron, 1 is not paired, and then for that single electron, I need one more friend electron. So when I need that one friend electron, and that's when I'm going into the picture where I'm going to combine them. So when I'm combining them, so consider they are becoming friends with another person, and then that's where they're becoming stable. And then ionic bonding, covalent bonding will come into picture, right? So if let's say, for example, if you can see example 1, carbon, the proton number is 6. And how do I arrange the electronic configuration? Proton number is 6 means, and then first shell I must have 2 electron, and my last shell must have 4 electron. So combining all together, I will have all 6 electrons, right? And example 2, the chlorine proton number is 17. So that's when, if you can notice on the board, so the electronic arrangement, the first shell supposed to be 2, second shell supposed to be 8. So that already complete 10. And then I have 7 more because my total number of electron is 17. So the last shell supposed to have 7. So in order for me to identify 2, 8, 7. So that is known as electronic configuration, right? Ions. Who are ions? So all that I'm talking about here are only atoms, elements. Ions, they come into picture where they are donating electron or when they are taking the electron. So why they have to donate and take the electron? As I said just now, if a friend must be stable means we must have 8 valence electron in the valence shell. That's when 2 friends in that relationship, they will be stable, right? And then when they are stable, only the bonding will be correct. So in order for me to create the bonding, the last shell must be stable. So the last shell to be stable, it must have 8 valence electron, right? So if let's say my sodium, for example, sodium is in group 1. So the final shell will have only 1 valence electron. So that 1 valence electron don't have a friend now. So I need to find for a friend that 1 valence electron. So when I'm finding for that 1 valence electron, I have to bond them. So when I'm bonding them with another person, with another element, so that's where the sodium gonna be stable, right? So if let's say sodium is stable by donating that 1 electron. So if let's say imagine there is a person full with electron negativity. Electron is negative charge. Proton is positive charge. Imagine a person with full of negative energy, negativity, electron and everything. And then they want to give away that one particular negative energy to the other person. So when they are giving away, are they becoming very calm, pure and everything? So they become very positive, like they become very good. So if let's say they are giving off one of their negative characteristics, they're becoming good. So when a person becoming good, they become positive. So that's how sodium, by donating that 1 final valence electron, it will become sodium positive. When sodium is giving that 1 electron, the particular friend who's taking that 1 electron from them, taking the negativity to them. But then by taking the negativity to them, what is happening? They're becoming negative. This is very wrong, but it's happening. But then by doing this, only the bonding between them is going to be stable. So by doing this, another friend, by taking that electron, he's going to be negative. So that's when it will be a negative charge. So if you notice, your oxygen here is 2 negative. The first diagram showing 2 negative. So 2 negative, you cannot say it's 2 minus 2 plus. 2 minus plus and all that, it's in mathematics. In chemistry, we have to mention positive, negative charge. And whenever you are writing the answer, you must mention the charge. Only the charge will identify whether it's ion, whether it's element alone, compound, whether it's a neutral compound, then only it will tell you. Understand? So my oxygen is becoming oxygen element when it don't take any electron. But oxygen becoming O2 negative when it's taking 2 electrons from the particular friend. So that particular friend can give 2 electrons to them. So when they are taking the 2 electrons, the negativity from someone, then oxygen becoming negative. While going to lithium side, lithium, the final valence electron is 1, because as I said just now, lithium is in group 1. So the valence electron is 1. So the final, the electron in the final shell, it will be paired with another person's electron. Sorry, another person. So lithium, what lithium gonna do? It will give away that electron. So I don't want this negativity. I'm giving away because I'm already okay with my 2 electron in my first shell. So my second shell got 1 means I don't want that. So I'm giving away to my friend, it's okay. But then another friend who is taking the electron becoming negative, but then has to. But then lithium is giving away that electron, means the lithium becoming positive, because when you're giving away that particular electron. So when I'm having the charge, whether two negative charge or positive charge, that charge will tell me whether it's an ion or not. So element won't have charge. So whenever you see a charge on top of an element, that is considered an ion, right? Molecule, what is molecule? So this is very basic and back to very basic lah. But I'm sure some of you might remember it, but some of you might have missed a touch of it. So let me go back to like recap that thing a bit. So molecule is a small particle. So when there are more than one atom, it is considered molecule already, right? So substance melt, it is weak intermolecular force. So we have ionic bonding and covalent bonding in order to combine these molecules. So ionic bonding will always happen between metal and non-metal, right? So usually metal, and the another pair of ionic bonding will be non-metal. So anion, negative. So remember always anion is negative, cation is positive. So anion are formed when atoms, usually non-metal, gain electron. So as I explained just now, whoever gaining the electron, whoever gaining the negativity, they become negative charge, right? And also they will be considered as an ion. And the person who is giving, cation. So cation is basically positive because they are giving away the negative energy. Next, covalent bonding. Covalent bonding will be usually sharing of electron. Ionic is very good heart. Ionic bonding, very good heart people. So metal will always give and non-metal will always take. It's a give and take relationship. But by covalent bonding is more than that. Covalent bonding is very understanding. Covalent bonding will share the electron. So when they are sharing the electron, okay, for example, carbon bonding, carbon with hydrogen. So carbon need 4 electrons in the valence shell. So carbon with hydrogen, they always share the electron. Why they share the electron? Because both are non-metal. Carbon, oxygen, both are non-metal. They share the electron. So they become more understanding here. So they are sharing the electrons. Understand? So that's why covalent bonding is between the bond between non-metal and non-metal. They share the electrons between them, right? And the of 2 atoms to a shared pair of electrons. So it could be a pair of electrons. Okay, it must be a pair of electrons, and it could be more than a pair of electrons, right? So later I have a question to show you what is meant by more than one pair of electrons. Right, ionic bonding. As I said just now, it's between non-metal and metal. So if you notice, sodium and fluorine. So I'm going to use the board. So if you notice sodium and fluorine. So remember, when we are always drawing our electronic arrangement diagram, we always will draw the last final shell. So only the last final shell will indicate whether it should be shared or it should be donated, right? Donate, receive. Okay. My Na will always have 1 valence electron. My fluorine will have 7 valence electron, because my fluorine is in group 17. So my valence electron is supposed to be 2, 8, 7, and here I have 2, 8, 1. So this one I will give away, and this one I need 1. Okay, I need 1 electron here. I will give away this 1 electron, because by giving away I'll become stable. But my friend, by only taking this only will become stable. Because imagine like this, whether to give 1 is easy or to give many is easy. So always people can ask, fluorine can give also what? Fluorine got 7 electron, fluorine can give also what? Sorry?
It's 27, not 2.
Oh, 27. Okay, sorry. It's in which period? Sorry, period 2. Yeah. So period 2, so 27 only. Sorry for the error. It's not error basically. So it's period 2 and period 3. So period 2 only have two set of shells, and then period 3 will have 3 sets of cells. So when I'm doing my 281 and 27, this means that this one I have 3 shells, this one I have 2 shells, right? This is why your periodic table is important, remember. Okay, your periodic table is important, and don't think that I won't need the periodic table at the back of the page of my question paper. I won't need it. No, there's no such thing. You will need it. Because see, you have to know how many periods are there and how many electrons are there. One thing. Okay, if let's say, coming back to sodium and fluorine. So it's like this. So my fluorine need 1. So when I'm combining them, I'm gonna give, and this fella gonna take. So when giving this and giving this, my sodium will become, the last shell will become 8. How, teacher, 8? Because just now I didn't draw my first 2 shells. My first 2 shells had 2, 8 and 1. I'm already giving away that 1. So my final shell not into any count already. So my final shell gonna be the second shell just now, which has 8 electrons. And this one will have, fluorine will have, the final shell will have 1, 2, 3, 4. All the 7 will remain, but then here the 1 electron from sodium is given there, right? And this fella will become negative. Why negative? They have gained the electron from there. How will the covalent bonding will work? So before I go there, then I just follow the covalent bonding. Right. So how covalent bonding will work? Okay. Covalent bonding is all about sharing. So I will take covalent bonding of carbon and hydrogen, which is very straightforward and easy to remember and also easy to understand. Right. Carbon. The final shell suppose are only 4 electrons. Right. So 4 electrons, I need how many more electrons? Another 4 more electrons. So who can give me another 4 more electrons? It's either a person who can give 1 electron here, 1 here, 1 electron here, 1 electron here. It's either like that. It's either another carbon who willing to give me all that 4 electron one shot, or another person who can give 1 electron 4 times. So that means hydrogen got 1 valence electron, correct? Hydrogen willing to give that 1 electron, because hydrogen, by giving away, the hydrogen will be still stable. Okay, so hydrogen willing to give that. So hydrogen got 1 valence electron. When they are sharing the bond between here, they will share like this. The cross belongs to carbon, the dot belongs to hydrogen. So when they share like this, it's either you can draw this way. Remember, you can use this way to draw, or you have to mention like this. So clearly, this orbit belongs to carbon. So that's why I have a cross here. This orbit belongs to hydrogen. That's why I have a dot here. So it's either 2 way. It's either you draw like this or draw like this, right? So both ways will tell you that electrons being shared in between. So already share 1 here. So I have how many valence electrons for carbon now? So 1, 2, 3, 4, and 5. So I need how many more? I need 3 more. So I need 3 more. I already shared with hydrogen over here. So now by sharing this, hydrogen got how many valence electron now? 1 and 2. 1 and 2. 1 and 2. So when share already, your property is my property is your property. So that's how sharing works, right? Sharing money also like works that way, right? So when carbon giving away that 1 electron means hydrogen sharing that 1 electron means, that means that both electron will be applicable for hydrogen as well, for carbon as well. Okay, so when happening like this, I have 3 more space here. So I have 1 more hydrogen who willing to give the electron, I have 1 more hydrogen who willing this give electron, I have another hydrogen who willing to give electron. So now, if I combine all of them, so I have a cross here, cross here, cross here, and I have a dot here, dot here, dot here. So as I explained just now, all my dots are belongs to H, all my cross are belongs to the C in the middle. So if you count for only carbon, the final shell will have how many valence electron? 1, 2, 3, 4, 5, 6, 7, 8. Is carbon stable now? So carbon stable by having 8 final shell in 8 valence electron in the final shell. How about hydrogen? Hydrogen, we have 2 terms, which is duplet, octet. This duplet and octet, both who having 2 valence electron and also 8 valence electron, they are both stable, right? So hydrogen by having 2 valence electron now, they are also become stable, right? So that's how covalent bonding works, by sharing the electron. And the another way, that's how ionic bonding works, by donating and receiving electron. And remember, okay, this covalent bonding I already explained over there. This is just extra explanation over here, where they have also explained carbon dioxide. How carbon had 2 oxygen, so covalent bonding will give you the answer. Okay, and how H2O has 1O and 2H, covalent bonding is the answer, because both are non-metal. Okay, how I have lithium oxide, and lithium oxide are my molecular formula supposed to be Li2O. I have 2 Li and 1 O. So how do I get 2 Li? Ionic bonding is the answer. Why? Because lithium is metal and oxygen is non-metal. My ionic bonding is metal and non-metal. My covalent bonding is non-metal and non-metal. So that's why covalent is always sharing, while ionic is always donating and accepting. Understand? So we have 3 more slides. 5 minutes is just nice. So okay, good. Right. So how to tackle questions when it is involving drawing of this electronic arrangement. Okay. So show the outer electrons only. Show the outer electrons only means I only want to know the outer electrons arrangement. I don't want to know before that, after that. Okay. When they are asking CO and Cl. Okay, if you notice that, okay, if you notice here I have 1 C, 2 O. I cannot see the cursor here. Okay, never mind. So I'll just draw. Okay. So if you can see, there's double bond over here. There's double bond over here and single bond, single bond. 2 lines which connects one atom to another atom, that 2 lines will indicate that it is double bond. 1 line will indicate single bond, right? So if you can notice, when I'm having a single bond here, when coming to here, I'm sharing 1 pair of electron. Okay, I'm sharing 1 pair of electron in the sense of I have 2 electrons. 2 electrons in 1 means 1 pair. Okay, 1 pair of electrons. But if you notice here, I'm sharing 2 pairs of electrons, which is 4 electrons over here. So because my O having 6 valence electron, while my carbon has 4 valence electron. So 1, 2, 3, and 4. My oxygen will have 1, 2, 3, 4, 5, 6. So 6, I need how many more electrons for the oxygen to be stable? I need 2 more. So that 2 more will be given by my carbon over here. So it's either like how I explained just now, I draw this way in the middle, or I'll draw this way. Okay, it's a straight line between or meaning in between the middle of the sharing space or on the orbit. It's either way. Even here, I can draw also like this, X and dot. Okay, so it's either in the middle of the sharing space or on the orbit. So there are two ways, right? And chemical equation, always remember you have to balance the chemical equation. Non-balanced chemical equation will not give you the final answer, will not give you the marks, and will not help you to identify any calculation. So whichever questions containing calculation, whichever questions involving all these arrangements, involvement, all these need balanced equation, right? And here, if you notice, they are asking sodium fluoride. Sodium, clearly metal. Fluoride, clearly non-metal, halogen. So metal and non-metal, before they even tell you, you're supposed to know it is ionic bonding. And ionic bonding, always remember, you must have this bracket over here. If let's say the bracket is not given, the bracket must be here and the charge must be here. Only the charge will tell you electrons have given and taken, right? Again, another example, fluorine and fluorine, sharing one pair of electron. Why? Because both fluorine are non-metal. Okay, this is an arrangement of covalent bonding. As you can see, dot and cross. It's either a dot like this, not round like this. This is considered circle. Okay, your electron supposed to be a dot or cross. That is what they meant by dot cross. Understand? And again, repetition of another covalent bonding. And that's it. Electricity and chemistry and another hydrocarbon will be covered in the next session, which will be after this. And before that, I guess I'm done with the first session. Is there any questions? If there's no questions, then we might end this session and see you guys after the lunch break. Thank you, everyone.